Hi, everybody. All right, well, we're going to be on day 2 of final review. If you are testing, I understand they may be behind. If you are doing 11th grade assessments and you're watching this late, that is understandable. You do have some extra time to take your final. Seniors, you need to take your finals. Your grades are going to be due. They are due before everyone else's. So just note that. Make sure you guys are caught up. And if you come across other questions, you're not sure about something, let me know. Send me a message. Remind is the best way to get a hold of me. But let's go ahead. Let's get started with our first question. So again, a little bit of review of everything we've done first semester. Some of the stuff is from first semester that we've already some prior knowledge that builds on for second semester. So you might see some stuff that does go back to first semester, just because we're using it in a different way or as a foundation for something we are doing this semester. All right, so matrices, good old matrices. First thing we're going to do here is we're asked to take the system of equations and we need to put it into a matrix form, and we want it so that's going to be an XY matrix is equal to something. So first thing I'm going to do is I'm going to take the coefficient matrix. Remember, the coefficient matrix is taking the coefficients of our X and Y values. So when I look here, I have 3 and -2, 6 and -5. So these are the coefficients of each equation. So this was my equation 1. Oops. My equation 1. This is my equation 2. And again, these were my X values. These were my Y values. And remember, when we multiply a matrix, in order to multiply it, it has to have the same. Well, let's write this out so we can actually close. Dimensions of this one is a 2 by 2. And if I'm going to multiply this, then my inner values have to be the same. Remember, the inners have to be the same. So I'm going to have a 2 by something here. And what's going to go here is going to be our X, Y values. That's right, because when I multiply this, it's 3 times X plus -2 times Y. So I'm ending up with my same equation. I'm ending up with this piece. I'm not changing anything. I'm just changing the format that it's written from a system of equations into a matrix, but it's still representing the exact same thing. So this would be a 2 by 1. So remember, when I multiply matrices, they have to have the same inner dimensions. My new matrix would be my outer dimensions. So what this is going to be equal to is it's going to be equal to my solutions here, -3 and 9. Okay, so let's look at this. Well, let's say that I have an equation where this is I'm going to call this my matrix A times X is equal to B. So if I have A times X and I have it equal to B, and I want to solve for my X value here, if I want to get X by itself, then I would need to multiply A by the inverse. And what I do to one side, I have to do to the other. So I would have to multiply A inverse to that B as well, so that these two cancel out. And that unknown, that X is equal to A inverse times B. Because I want it to be in that unknown format, that X, Y, I want to get this by itself, I need to get rid of this matrix. And the way that I do it is by taking the inverse matrix, so that it becomes X equals A inverse times B. So that's going to be my goal, is to get this equation, this matrix, to look like this. So first thing I'm going to do is I need to figure out, well, what is the determinant of A? So why do I need the determinant? Because remember, the inverse is going to equal 1 over my determinant of A times. And to find the inverse, I switch my A and my D spot, and I would take the opposite signs of my B and C spot. So this becomes a negative and negative. They're the opposite signs of my B and C. So if I want to find the inverse of this equation here, it's going to equal, my determinant is going to be, do it off to the side here, 3 times -5 minus 6 times a -2. So 3 times -5 is -15, a -6 and a -2, they become positive, so +12, and my determinant is a -3. So I end up with 1 over my -3 times, I switched my 3 and my -5, so it's a -5 and a 3. My -2 and 6, they're going to become the opposite sign. So since this was a negative, it becomes a positive, and this positive becomes a negative. Now remember, this -1/3 goes to each and every piece. So I could distribute that through. So I end up with A inverse is equal to 5, I almost said 1/3, 5/3, a -2/3. -6 divided by -3 is +2. 3 divided by -3 is going to be a -1. So when I go ahead and I want to solve for my xy, then it's now going to be xy is equal to, it's my A inverse, so it's going to be my 5/3, -2/3, 2 and -1 times my B, which was -3, 9. So again, this is matching my equation up here. X is equal to A inverse times B. So here's my solution. We're done. That's going to match up with this first one right here. Sometimes you guys might not realize, well, how do I know it's not this one when we forget about the order? Remember, when you multiply, you have to multiply your rows by columns. And if I look here and I try to multiply, they don't match correctly. I can't multiply those together. So that's not even going to be an option. So I don't even have to worry about which one really, because only one way is going to work. So just be careful about that. Moving on, next problem. We are going to be working with area of triangles. So they gave us our formula. We already know we're going to be using this formula. They gave it to me. That's pretty awesome. So I know I'm working with a triangle. It says I have triangle RST. I have one side that measures 22 inches, one side that's 13, and a perimeter that's 50 inches. So I know that the whole perimeter of the triangle is 50 inches. So here's my triangle. I'm going to just call this RST. And I have one side that's 22 inches. I have one side that's 13 inches. It's not to scale. And this other side, I don't even know what it is. But I can figure it out because I know my perimeter. So if I want to solve for this missing side, I know that X is going to be 50 minus what's 22 plus my 13, that's going to be 35. So minus 35 is going to equal 15. So I know that this side is 15 inches. Why do I care about that side? How come I even bothered with it? Well, if I look here, that's what this A, B, and C represent, are each one of my sides of my triangle. There's my A, B, and C. But in the formula, there's also that S value. Sometimes we forget, how do I solve for S? Well, in order to solve for S, I needed my perimeter. So I needed to know what the sum of them all are, but I also need to know them individually because those represent this A, B, and C. So my perimeter is 50. The value of S is my perimeter divided by 2. So in this case, it's going to be 50 divided by 2, which is 25. So when I go to solve for my triangle, it's going to be the area of the triangle is going to equal the square root of S, which is 25. Then it's going to be 25 minus each one of my sides. Doesn't matter the order. So I'm going to do 25 minus 22, 25 minus 13, and 25 minus my 15. And then I'm going to go ahead and clean it up, and I get A is equal to the square root, and I'm going to have 25 times 3 times 12 times 10, which is going to equal the square root of 9,000. Plug that into my calculator, and I end up with A is approximately 94.87. And so I look here and it says round to the nearest square inch. So when I want to round this to the nearest, it's saying the whole number, and it's going to be 95, and there's my answer. If I go too fast on anything and you didn't catch it, you're more than welcome to send me a screenshot of where you're lost, or just ask me any questions you guys need. Again, get to me through Remind. On this one, if you watched the video, when I forgot to do the lesson that day, I thought I had it. This is the problem I used for it, so it's kind of a replay. These ones have the graphs for you, which is really nice. You don't even have to plug them into Desmos. If you wanted to, you could plug each one of these equations into Desmos and see what matches. Kind of more time consuming, but personal preference. So if I look here, first thing I would do is I would identify my vertex. So this one's going to be a y equals. My vertex here is going to be at 0, 1. So here's my h and my k values. Since it's a y equals, my equation would be something like y minus k equals some x minus h squared. And everything I'm going to do right now is equals because I don't know which way the sign is going to go. We're just talking general form. So I know then that this is going to be y minus 1 is equal to some x minus 0 squared. I want to bring the 1 over. So I have y is equal to x squared plus 1. And I can see that it's going to match one of these two. I don't know exactly what that sign is going to be, but I know that that's not going to match my graph here. Very similarly, I already know that my graph has to be one of these two, but I could look here for my second portion. I know that this point here is at -8, 0. I know it's a y equals, or sorry, it's an x equals, well, it's going to be a y equals, it's going to be an x is equal to, because it's going left and right, so my y is going to be squared. So I know it's going to be some x minus h is equal to some y minus k squared. And in this case, here's my hk. I'm going to have x minus 8 is equal to y minus 0 squared. Again, I'm bringing over that 8. So I'm going to have x is equal to my y squared plus 8. So I could, sorry, the negative there. So that should be a plus, and that's going to be a negative. So it's x minus h, so it's x minus my -8. And so I could see that it's going to match right here. So I know it's one of those two. My problem is I don't know which way my signs go. So you need to check it. So pick a point. Pick a point. So if I pick this point right here at 0, 0, it is neither in this equation here, it's not in this equation, and it's not in this equation. So they would both have to be not true because it's not in either of them. If I pick a point here, if I pick this point here, this point here is not included in my yellow region, but it would have been included in my blue region. So it would have to be true for this equation and not for this equation. Kind of gets complicated when you start thinking about things like that. So one strategy could be to pick it so that it's not in both, or something that is in both. Whatever you prefer. So this one, I'm going to go ahead. I'm going to choose the point. I'm going to pick 0, 0. And it's not in either equation. So it should be not true for both. It's not true because it's not shaded. It's not shaded in either equation. It's not shaded in either, which means it's not true for both. If it was shaded, then it has to be a true statement. So here's what I'm going to do. If I plug in 0, 0 into this equation, so here's my x and my y, plug in 0, 0, I would have 0 is what to 0 squared plus 1. In other words, 0 is, 0 is what to 1. And we want this to be not true. So I would have 0 is greater than or equal to, or less than or equal to. So is 0 less than or equal to 1? That's true. It is less than 1, but it's not greater than or equal to 1. So I would have to pick the one that makes it not true. And in this case, it would be greater than or equal to 1. 0 is not greater than or equal to 1. This is not a true statement, which matches with this one right here. So I know this has to be my answer, but I always like to double check my work. So I make mistakes all the time, right? I think ahead and I'm like kind of going too quickly. We all do that. All right, so let's double check. So this one has to also be not true. So if I plug in 0, 0 for this, I would have 0 needs to be less than, well, if I want this to be not true, let's see. So less than 0 squared minus 8, 0 is less than -8. Is 0 less than -8? That is not true, which is what we wanted. We wanted that. We wanted it not true because it's not shaded. So this is my correct answer. They were both not true. And again, I picked this point here that is not in either region. All right. Next one. Vectors, our vectors. So again, this is a good review of a lot of different pieces that we've been working with. Vectors. This one asks for the angle between the vectors, the angles between the vectors. And so when I look here, I'm quickly going to sketch this. So I'm going to be at 1, 2, 3, 4, 1, 2, 3, 4. So I have my 3, 4, and I have my 4, 3. So if I have my vectors here, the angle between the vectors, I know that that angle is going to be less than 90 degrees, right? I know it's less than 180. I know it's an acute angle because of where these points were plotted. So I can, just from knowing that, kind of look here and see. But how do I figure it out? Sometimes it's not always that simple. Sometimes it could be an obtuse angle. And so if that's the case, remember when we have restrictions and sometimes we need to add 180, use the idea of plotting them to see how big is that angle going to be or not. So we're talking about going from here to here. Okay. How do I calculate this out? This just gives us kind of a visual of what's going on. Maybe we had multiple acute angles to choose from. It's not always so easy and obvious. So if I want to find the angle between vectors, we use our formula cosine of theta is equal to the dot product of u and v over the magnitude of u times the magnitude of v. Remember, magnitude means the distance between them. So the distance or how long they are. So not actually between the angles, but the distance from our origin to that point. How long is the vector? So if I want to figure out the dot product of u and v, so this is my u, my v, the dot product, u dot v is equal to, I multiply the first numbers together and I add it to the multiplication of the second two numbers. So it's going to be 3 times 4 plus 4 times 3. So it's going to be 12 plus 12, which is going to give me 24. So the dot product of u and v is 24. But I've also got to figure out my magnitude of u and my magnitude of v. So let's look here, the magnitude of u. So magnitude, the length of u is going to be the square root. I square the first term and I add it to the square the second term. So it's 3 squared plus 4 squared. So it's going to be the square root of 9 plus 16, which is the square root of 25, which is just the square root of 25 is just 5. So the magnitude of u is just 5. But I also need to find the magnitude of v. So the magnitude of v is going to equal, and I look here, it's going to be the square root. In this case, it's 4 squared plus 3 squared. Look, they happen to be the same numbers. It's a 4, 4 squared, 3 squared, 3 squared. So some of you guys can already tell right away, it's just going to be the value of 5. Maybe some of you guys work it out all the way and you're still going to end up with 5. So they just switch the order of them. It's still the same value. That's okay. That doesn't happen all the time. Just in this problem, they happen to be a 3, 4 and a 4, 3. So now I go ahead and I can solve for that angle. When we talk about solving for the angle, we're looking for our theta value. That's what we want is theta. So I plug in everything I know. So I have cosine of theta is equal to 24 over 5 times 5, or 24 25ths. So I want just the angle though. So I need to get rid of this cosine. So I take the inverse, and what I do to one side, I do to the other. So I end up with theta is equal to cosine inverse of 24/25, and I would put this in my calculator. Now notice they're all in degrees. So when I put in my calculator, I want to make sure that I'm in degrees. And I put it in, and I get that theta is going to be equal to 16.3 degrees, and there's my answer. And we're done. All right, and our last one. This is also going to be a vector problem. So this one says we have air traffic controllers watching two planes on a radar. And it says that plane A took off at 10 a.m., plane B took off on the same runway 5 minutes later. So planes go on the runway, they're heading the same direction angle, they're the same direction angle and on the same path. It's saying then at 10:10, the airport's radar system detects plane A is going to be at coordinate 24:18. So I'm just going to give us a quick little visual here. So I'm at 24:18 is going to be my plane A. So plane B is going to be at 8:06. There's my plane B. So I have plane A 24:18, plane B 8:06. It also adds the scale on the radar is 1 unit is 25 miles. 1 unit is 25 miles. So when we talk about this magnitude, we don't have a specific value with it. These are going to be, it's 5 units long. This would be 5 units long. So in this case, they're telling you that 1 unit is representing 25 miles. But when we solve for the magnitude or for the distance of the vector, we always just use it in terms of units. So this continues and says, which vector represents the path from plane A to B? So I'm here at A and I'm going to B. So this is where I'm starting. So this would be what we would call our initial point. This here where we end or where we're going to would be our terminal point. So when we want to figure out the path, we're talking about the component form. We would go ahead and use our component form. And what that does is it's going to be your, remember it's it's terminal minus the initial. So when I want to find the vector that represents this path, we want to take it, see how these are in a coordinate form? We want to turn it into a vector. And so I'm going to use vector notation. And what we're going to do is we're going to take the terminal side with the corresponding x value, and we're going to subtract it from the initial side. So it's going to be 8 minus 24. And then we're going to go ahead and we're going to do the y values, and we're going to do 6 minus 18. So it's terminal side minus the initial side. It's always that way, minus 18. So the component form for a vector would be -16, -12. So we know we're going to cancel off these two right here. So when we talk about this path, we're talking about the component form. And it also says, what is the actual distance between them? Distance. Again, this is going to be talking about the magnitude. Magnitude is another way to say the distance. So let me retry that again. So magnitude, sometimes talking and spelling doesn't go hand in hand. So when we talk about the actual distance, we want to know the magnitude of our vector here. So just like we did over up here, we're going to do the magnitude of my vector V is going to be, I squared the first term, so -16 squared, and I added to the square of the second term, so 12 squared, and I get the square root of 256 plus 144, which is going to be the square root of 400, which is so pretty, and it's just a value of 20. And I look up here and I'm like, oh, sweet, here's my -16, -12, and my 20. And most of you guys will run and pick that answer. And I'm like, no, don't do it, because this is 20 units, and this is miles. We are told that 1 unit equals 25 miles. So you have to make sure you are reading your problem. We know 1 unit equals 25 miles. And I have 20 units. So that's going to equal 20 times my 25, which is going to give me my 500 miles. So our correct answer was this one right here. Don't let it trick you. All right, you guys have a great day. Video 3 will be out, so if you want to watch them all at once or one each day, whatever works best for you, but they are here. They're all problems from the review. Message me if you have any other ones. Take care.